Hello friends, welcome to Learner's Planet. Friends, this is our fourth problem solving on circles. We have already done two basic sessions in which we discussed the theorems, basic concepts and terminologies related to circles, and three more sessions I have already done with the basic problems, basic and some moderate level of problems. In this session, once again we'll be discussing some more problems, and once again my suggestion is do not come to this session before you attend the previous sessions, right? And when you're coming for this session, be ready with your paper and pen and try to do the problem on your own, right? Just pause the session when the problem appears on the screen and try it on your own before you see the explanation. Okay, so let's begin the session. Let's see this question. In the figure, AB is tangent to the circle at B and ADC is a straight line. If AB is to AD is 2:1, then area of triangle ABD is to area of triangle BCD. ABD and BCD. Precisely you have to find out the area of these two triangles. Triangle 1 and triangle 2. Right? Now base is on the same line. So altitude will be same of both the triangles. Okay? Now AB is 2x and AD is x. So AD is x and AB is 2x. Okay. And I assume DC to be y. DC is not necessarily to be the diameter of the circle. So do not treat it as diameter. Now we know tangent second theorem. I have already discussed this in basic session. From a point outside the circle, if we drop a tangent, then AB square is equal to AD into AC. That is tangent second theorem. ADC, it is secant of the circle. So the segments will be AD and AC. So AB square is equal to AD into AC. Okay, now what we do is we put up the value of AB, AD and AC. So AB is 2x, so AB square will be 4x square, AD is x and AC is AD plus DC, that is x plus y. So x plus y is equal to 4x, that means 3x is equal to y, or we can say y is equal to 3x, right? Now since altitude of both the triangle is same, their area will be in the ratio of their bases, right? So base of triangle ABD is x and base of triangle BDC is y, right? So ABD base is x and BDC base is y, that means 3x from here, right? So ratio will be 1:3. Since the altitude is same, the ratio of their areas will be the ratio of their bases. Okay, so that is 1:3. So we have used tangent second theorem over here to find out the solution, right? If you know this, it will be very easy for you to solve. In the figure, A, B and C are points lying on the circle. AB is the diameter of the circle. DB is the tangent to the circle at B. ACD is straight line with AC is 4 and CD is 2. Then AB is equal to, okay, very simple. We have just discussed a tangent second theorem. Here DB square is equal to DC into CA, right? DB square is equal to DC into CA. So DB we don't know. DC, that is CD, that is 2, and DC into DA. Okay, DA will be DC plus CA. Here CA is 4 and DC is 2, so the total is 6. So DB square is equal to 12. So DB is equal to root 12, right? Now AD, the complete length is 6. Now this is this sort of triangle. This is 6, this is root 12, and this we have to find out. That is the diameter of the circle, right? So x square plus 12 is equal to 36. So x square is equal to 24, or I can say it's 2 root 6. So pretty simple. Friends, in this problem I am introducing a new formula, uh, that is cosine formula for any triangle. Suppose I have this triangle ABC. The length opposite to this is A, length opposite to this is B, length opposite to this is C, right? Then cosine formula, cos A is equal to B square plus C square minus A square upon 2BC, right? Similarly, cos B is equal to A square plus C square minus B square upon 2AC. Similarly, cos C, right? Now what is important thing over here? Suppose you know the dimension of the three sides, right? Suppose you know the values of the three sides or the length of the three sides of the triangle, then you can easily calculate the angle, right? So without this formula it's difficult to calculate the angle between the two sides, right? So the same will be using over here. So that's really important. Sine formula I have already discussed with you, and cosine formula, this is new for you, so just note it down, right? So whenever the three sides are given and if you are interested in finding out the angle between the two, you can easily find out using cosine formula. Now how am I going to use it over here? Just listen to me carefully. In the figure, ABCD are points lying on the circle. AB is 5, AB, AD, BD, these are given, and we have to find out angle BCD. We have to find out this angle. Now ABCD is a cyclic quadrilateral. That means sum of this angle and this angle should be 180 degree, right? So if we can find out this angle, we can easily find out that angle. But how do we find out this angle? Because we just have the dimensions of the sides, right? We don't have any angle measure. So here we'll be using cosine formula, right? So cos A will be 5 square plus 3 square minus 7 square by 2 into 5 into 3. Okay. Cos A is equal to 5 square, that is 25, plus 3 square, that is 9, minus 7 square, that is 49, upon 2 into 5 into 3. Okay, very easily you can learn. Whichever angle you are taking, just take the sides which are meeting over here, okay, which are intersecting over here. So 25 minus 40, that is minus 15 by minus 30. I'm sorry, 30, so it is minus half. So cos A is minus half. So when cos theta is minus half, when theta is 120 degree, right? Cos 120 degree is minus half. Okay, you might have learned this in the trigonometrics session. Cos 90 plus 30 is minus sine 30. So it is cos 120 is equal to minus sine 30, right? So sine 30 is half, so cos 120 is minus half. That means cos A is minus half. That means angle A is 120 degree. So if this angle is 120 degree, it has to be of 60 degree, because sum of these two should be 180 degree, right? So pretty simple. I hope you are getting it. And cosine formula is really important. When you have the three sides, length of the three sides, you can easily find out the angle between the two. Okay, so here it's 60 degree. Now in the figure, O is the center of the circle. A and B are points lying on the circle. If AOC is tangent, AOC is a straight line, and BC is a tangent to the circle, then the radius of the circle is. Now here a point of contact is B, right? So if I drop the perpendicular, if I draw this radius, right, OB is the radius, this angle must be 90 degree, because angle between tangent and radius is 90 degree. Okay. Now OA is equal to OB, both of them are radius. So if this angle is 30 degree, it has to be 30 degree, right? Now see the triangle CBA, triangle CBA. This complete angle is 120 degree, because this is 90 and this is 30. So this complete is 120. So if this is 30, it has to be 30 only, right? Because it's a triangle. So BCA, it has to be 30 degree. and here do not get confused, angle CBO is 90 degree and angle OBA is 30 degree because OB is equal to OA, right? These two are matching, but this is 90, up to here it is 90 and then plus 30, so total is 120. Now since in triangle CBA this is 30 degree, this is 30 degree, that means this length must be equal to this length, so AB should also be 3. Now the problem becomes very simple. This angle is 30 degree, this angle is 30 degree, total it is 60 degree, so it has to be 120 degree, right? This is 120 degree, right? Now the situation is like this. This is 30, this is 30, this is 120, and side opposite to this is 3. And now we have to find out this length, right? Now we can use sine formula. Sine A by A is equal to sine B by B is equal to sine C by C, right? So here sine, I assume this to be A, B and this to be C. So sine A, that is sine 120 degree, by A, that is the side opposite to it, so it is 3, by sine B, that is 30 degree, side opposite to its AC, that is precisely a radius. Now third we don't require, so because we just want the length of AC, that is the radius of the circle. Yeah, so sine 120 is cos 30 and cos 30 is root 3 by 2. So and sine 30 is 1 by 2. So 1 upon 2 AC is equal to sine 120 by 3. Sine 120 is cos 30 is root 3 by 2, and this is 3. Sine 120 root 3 by 2 by 3. Okay. So AC is equal to 3 upon root 3. So it is root 3. So AC is actually do not get confused between these ABC. This is just a raw diagram over here. Here AC means this line, so corresponding this line over here, it's OB, actually that is the radius of the circle. So radius of the circle is root 3. Okay, do not get confused. I'm sorry, I just taken this ABC randomly, so do not get confused. This ABC is different. This triangle precisely it is OA B, right? So we calculated this length. So this OB is nothing but R, that is radius of the circle, so that's root 3, right? So I used cosine formula in the previous question, I used sine formula in this question. Okay, so when you have one length and one angle, then you can use sine formula. When you have all the sides but no angle, then you can use cosine formula. So both of them are really important, so just note them down. Now this problem. In the figure, O is the center of the circle and AOC is a straight line. Okay, if AB and BC are tangent to the circle, AB is equal to 3 and BC is equal to 4, then radius of the circle is. Okay, AB is 3, BC is 4, that means AC must be 5. Okay. Now I drop the perpendicular over here and here. So this is 90 degree, this is 90 degree. Suppose this is P, this is Q. OP and OQ, both of them are radius of the circle, and BPOQ it will be a square, right? Now friends, here I'll be taking bit different approach. I'll be using trigonometry to solve this problem. Now listen to me carefully. It is sometimes becomes difficult to initiate this concept, but if you practice well, you'll be able to recall, right? Now what I'm doing is, it's AB and it's BC. I assume this angle to be theta. Now this angle is 90 degree, so this angle must be 90 minus theta. Okay, so sum of these three is 180 degree. Okay, now I assume the radius of this circle to be R. So this is R, right? and since this is a square, it will also be r, and from external point both the tangents are equal, so this is also r. So precisely it becomes a square, and the side of the square is nothing but the radius of the circle. Now I take triangle OQC, triangle OQC, right? Over here I take, I am interested in this length, so, and this length, right, QC. So OQ is R, so this is perpendicular and this is base. So perpendicular by base, that is tan theta. So tan theta is equal to r upon, yet this total length is 4. So out of this, if r is deducted, this remaining length will be 4 minus r. So r upon 4 minus r. Okay. Now similarly in this triangle PAO. Okay, I am interested in this and this. And apart from that, what else we can do is, see in this triangle tan theta is r upon 4 minus r. If we take this complete triangle ABC, still tan theta will be, can be calculated because this angle is same. So tan theta will be 3 by 4. Right? In this triangle it is 3, this is r by 4 minus r, and in the bigger triangle it is 3 by 4. So tan theta is same in both the cases. So r upon 4 minus r is equal to 3 by 4. So it is 4r is equal to 12 minus 3r. So 7r is equal to 12. So r is equal to 12 by 7. Again I repeat, this angle I assume it to be theta, then this angle will be 90 minus theta, though we don't require this. This complete length is 4, this length is r, so this remaining length will be 4 minus r, right? So in this triangle OQC, tan theta will be equal to perpendicular by base. So perpendicular is r and base is 4 minus r. Right? And in this bigger triangle, still this angle is theta. So in this bigger triangle, tan theta will be perpendicular by base. So it is 3 by 4. Right? So tan theta is r upon 4 minus r and tan theta is 3 by 4. Right? So both of them will be equal. So 4r is equal to 12 minus 3r. So by solving, 7r is equal to 12. That means r is equal to 12 by 7. Okay? So bit different approach, but if you practice well, you will be able to solve, you will be able to recall these sort of concepts. Precisely in examination, you should be able to recall the concepts of trigonometry when you are solving the problems on geometry. Sometimes trigonometry helps a lot in solving the problems from geometry section. Okay, I hope you are getting my point. Let's see this question now. In the figure, O is the center of the circle ABC. If angle OBC is 50 degree, angle ACO is 20 degree, then angle BOA. Now, O is the center of the circle. So OA and OC, both of them will be radius of the circle, right? So if OC, in triangle OAC, OC and OA will be equal, right? So if this angle is 20 degree, this angle has to be of 20 degree, right? Then this OB is equal to OC once again, because both of them are radii of the circle. So if this angle is 50 degree, this angle has to be 50 degree. So if this is 20 degree, this remaining part must be 30 degree, right? So this is 50, this is 50. Okay, then in this triangle, suppose I assume this point to be P. In triangle PBC, this is 50, this is 30, that is 80. That means it is 100. This portion is 100, right? Triangle PBC, this angle is 100. If this angle is 100, then this angle will also be of 100, being vertically opposite angles, right? They are same, right? Angle between two crosses they are known as vertically opposite angles and they will be same. So if it is 100 degree, it has to be 100 degree. Now we talk about triangle OPA. Here we have to find out this angle, right? That is angle AOB or BOA. This is 20 degree, this is 100 degree, so total it is 120, so remaining 60 degree is AOB. Okay, or AOP, precisely this angle. So this angle is 60 degree, right? Very basic concept. I hope you are getting it. Now this problem. In the figure, ABCD is a circle. If AC is the diameter of the circle and AB is equal to BD, then angle CAD. Angle CAD we have to find out. So first of all, what I do, I just draw this line because AC is the diameter. So when you see a diameter in the circle and you get a question when you have to find out the angle, then what you should do, the first of all you should try to make angle in semicircle, right? So here I have made an angle in semicircle, that's this. This angle must be 90 degree, right? Now I have this line DC. Now this angle and this angle, both of them are in same segment, precisely this angle. Only this part and this part, both of them are in same segment, so both of them will be equal. So if it is X, it has to be X. First thing. Second thing, this angle and this angle, same segment, that is this segment. So if it is 54, it has to be 54. Right? Just try to understand the concept because image is not very clear. So do not get confused. This is 54, this is 54. This angle is 90. So in triangle ABC, this angle is 54, this angle is 90, this complete angle, then this angle must be 36. Okay. Now we have to find out X. Now other information which we have from the question is AB is equal to BD. So if AB is equal to BD, then this complete angle in triangle ABD, this angle will be this angle, right? This complete angle will be equal to this angle because AB is equal to BD. So if it is 54, it has to be 54, right? So if it is 54, that means X has to be 18 degree. Okay, pretty simple. So angles in same segment are equal, the concept we have used over here. Now this question. In the figure, ABCD is a circle. AB produced and DC produced meet at E. If AC and BD intersect at F, then angle ABD. So precisely we have to find out this angle, angle ABD. Now you see here in this segment, angle ABD is there, angle ACD is there. So if it is X, it has to be X because angle in the same segment will be equal, right? Now this angle 82, this will also be of 82. Reason, vertically opposite angles, right? So vertically opposite angles are same, right? We are talking about triangle, this quadrilateral BFCE. Right? Now this angle is X, so this remaining part must be 180 minus X. Similarly, this portion is X, so this remaining portion must be 180 minus X because ABE and DCE are straight lines. So if this is X, this has to be 180 minus X. Now we got the four angles of this quadrilateral, that is 82, 30, 180 minus X, 180 minus X, and sum of all these should be 360. So I just write down the equation. 82 plus 30 plus 180 minus X plus 180 minus X, that should be 360, right? So 180, 180, 360. 2X is equal to 82 plus 30, so X must be 41 plus 15, 56 degree. So what we want, angle ABD, that is X, that is 56 degree. Pretty simple. Now this problem. In the figure, OAB is a sector of radius 2 cm if length of arc AB is 3 pi cm. that's a major arc AB, then the area of the sector OAB is. See, to be able to find out the area, we need this angle, that is angle AOB. Right now, radius is given to us as 2 centimeter. So the circumference of this circle will be 2 pi r. Right, circumference of the circle must be 2 pi r. So 2 pi into 2, that's 4 pi. Right, so the entire length, right, this entire length is 4 pi. Now this portion is 3 pi. That means the remaining portion is only pi. Right, so out of 3 pi, this portion is pi. That means from the total portion, this is 1/4. That means this angle is 1/4 of 360 degree, that is 90 degree. That means angle AOB is 90 degree. That means this sector is 1/4 of the circle. Right, so whatever is the area of the circle, 1/4 of that will be the area of this sector, because the center angle is 90 degree. Okay, so what will be the area of this circle? Pi r square, pi into r square, that is 4, and 1/4 of that will be the area of this sector. Okay, now pi r square by 4, pi into 2 square, that is 4 by 4. So pi is the area of the sector AOB, that is minor sector. Right, so since there is no option pi over here, so that means he might have asked the area of major sector. Right, so total area is pi r square, that is pi into 4, and out of that this minor sector is pi, so the remaining portion, the major sector, is 3 pi. Right, so this is the answer. Okay, in the figure, TS, SP, QP are tangents to the circle at T, R and P respectively. If TS is parallel to PQ, TS is equal to 3 and QP is equal to 12, then the radius of the circle is. Okay, so precisely, see, TS is equal to 3. So if TS is 3, SR to be 3, should be 3, because from excellent point the length of the tangents are equal. Right, so if it is 3, it has to be 3. Second thing, PR is equal to, QP is equal to 12. So if it is 12, it has to be 12. For the same reason, from excellent point the length of the tangent should be equal. Right, so this per complete length SQ is now 15, PQ is 12, TS is 3. Now since this line is parallel to this line, what we can do is we can draw the diameter of this circle. These two are tangents, so this angle and this angle, both of them will be 90 degree. What I do now, I draw a line parallel to this over here. Okay, now TP will be equal to this I assume this point to be, say, X. Okay, so TP will be equal to SX, because this line is parallel to this line. Right, now I got a triangle SXQ. Here SQ is 15, 12 plus 3, 15. This length TS is 3, so PX must also be 3. So this total length PQ is 12, PX is 3, that means XQ must be 9. Right, now we are getting a right angle triangle like this. This is 15, this is 9, so 3, 4, 5 Pythagorean triplets are there. So it is 9, it is 12, it is 15. So 9 and 15 are there, so the third length must be 12. Right, so this length is 12. That means SX is 12. If SX is 12, TP will also be 12. If TP is 12, that means diameter of the circle is 12. If diameter is 12, radius must be 6. Right, so simple, no much paperwork is required, 100% conceptual problem. If your concepts are good, then you can solve this sort of problems very easily. Otherwise you will definitely stuck up. Okay, so I hope you are clear. In the figure, ABC is a circle. If angle ABC is 30 degree, arc length AC is equal to 4, then the circumference of the circle is. now seems to be difficult because no data is there to find out the circumference of the circle. To be able to find out the circumference of the circle, you need to have radius of the circle, right? Now how would we approach the problem? So this arc AC is given to you and this angle 30 degree is given to you, right? Now this angle is made on circumference of the circle, right? Now from same arc, if I make the angle on the center, that will be that should be double of this. So what I do, I just draw the angle at the circle. Suppose this is a circle, so from the same arc I draw the angle on the circle, right? Now we have already discussed the concept. From the same segment, if angle on the circle is 30 degree, the angle at the center must be 60 degree, right? Now so the center angle is 60 degree and this arc length is 4. So 60 by 360 of 2 pi r is equal to 4, right? This arc length is 4, this arc length is 4 when this angle is 60 degree, right? So this angle is 60 degree out of 360 of the total circumference, and that is actually 4. So only r is the unknown quantity that can be calculated very easily. So it's 2. So r is equal to 12. Or precisely we have to find out the circle, so that's 60 upon 360 into 2 pi r is equal to 4. We want 2 pi r, so just cancel it, and 60 by 360, that is 6. I multiply this, so 2 pi r is equal to precisely 24, right? No need to find out the radius of the circle. If you have told you have to find out the radius of the circle, then find the radius. Otherwise directly you can find out the value of 2 pi r. Okay, so that's 24. I hope you are clear. So if you know this concept, that angle in from the same arc, if the angle at center, if it is angle at other part of the circle is 30 degree, then angle at the center must be 60 degree. Otherwise you cannot solve this problem. If you don't know this logic, you cannot solve this problem, right? So there is a good recap of the concepts we have discussed in the basic sessions, right? Move further. In the figure, ABCD is a circle. AC and BD meet at E. If AD is equal to 4, AE is equal to 2, EC 5, BE 4, then BC is equal to. So we have to find out length BC, that is this length. Okay, now once again we'll have a quick recap of a concept. See, AC and BD, none of them is diameter, right? First of all, AC and BD, both of them are chords of this circle, right? And when they are intersecting at the point E, product of their segments will be equal. That means AE into EC, that is 2 into 5, should be equal to BE into ED. So BE is 4, ED is, I suppose, X, right? So X is equal to 5 by 2, or I can say 2.5. Now this angle is equal to this angle, vertically opposite angle. Now just see these two triangles carefully. Triangle ADE and triangle ECB. This length is half of this length. This length is half of this length. And this angle is equal. These angles are equal. That means triangle DAE is similar to triangle BEC, right? If the two triangles are similar, their sides will be in ratio, right? We can see it is 2.5, it is 5, it is 2, it is 4. That means the third side should also be in the same ratio. So if it is 4, it has to be 8, double of this. Okay, so if AD is 4, BC must be 8. Simple. So here we have used the concept of this chord intersection of two chords, as well as the concept of similar triangles. So if your triangle concepts are clear, if your circle concepts are clear, the problems from circle as well as triangles, you can solve them easily, right? In the figure, AED is arc AED is 1, CFD is 4, angle ABC is 100, find angle ABD. Okay, over here arc AED, arc length AED is 1 and arc length CFD is 4, right? So what we can do is we can find out the ratio of their center angle also. First of all, I just complete the figure, I draw the center. So suppose this is the center. This is arc AED. Similarly, this is arc CFD. Okay. Now what? See, what is the formula of arc length? A very simple concept I am discussing over here, though you must be knowing it already. What is the formula for arc length? That is theta by 360 into 2 pi r. Right? So I assume this angle to be x. Okay, AED is x, right? So x by 360 into 2 pi r, or I assume this to be suppose y. So x by 360 into 2 pi r is equal to 1, that is the length of this arc, and y by 360 into 2 pi r is equal to 4, that is length of this arc, right? So you can very well see the ratio of arc length is nothing but the ratio of their center angle. So x by y is also 1:4, right? So if it is x, it has to be 4x. Okay. So if length of arc is double, the center angle will also be double. If length of the arc is 4 times, the center angle will also be of 4 times. So if this angle is x, this is 4x. So this complete angle is 5x. Okay. Now you can see from this segment, segment AED, this is from this segment, this is angle at the center, this is angle at the center, and this is angle at the circumference. So if it is x, it has to be x by 2, right? And we have been given angle ABC as 100, angle ABC as 100. This complete angle is 100. Now what? This portion is x by 2 and this complete portion is 100. That means only this portion will be 100 minus x by 2. Okay, only this portion will be 100 from the complete angle. If I deduct x by 2, this angle will be 100 minus x by 2. Now from this segment DFC, this angle should be double of this, right? Angle at the center should be double than that of angle at any other part of the circle from this segment. Okay, so this is actually 4x. So 4x should be double of 100 minus x by 2, right? So only x is the unknown quantity over here, so that can be calculated very easily. So 4x is equal to 200 minus x. So 5x is equal to 200, x is equal to 40, right? So this angle x is equal to 40, but we want angle ABD. Angle ABD, that is nothing but x by 2. So if x is 40, x by 2 is 20. Okay. So first of all, to initiate the problem, you must be knowing the arc length. If the ratio of arc length is 1:4, the ratio of their center angle will also be into 1:4, right? This is not at all required to write, right? You don't have to write in your exam. Just for clarity of the concept, I have done this, right? When you got to know the center angle, that is ratio is 1:4, then again the same concept we have used. Angle at the center is double than that of angle at the circumference. So if this is x, it has to be x by 2. After that, the complete angle is 100. So this part only will be 100 minus x by 2. On the same segment, this DFC, on the same segment, this is the angle at the center, and this is the angle, this is angle at the circumference. So this angle should be double of this angle. So this angle is actually 100 minus x by 2. So it is 100 minus x by 2, it is 4x. So 100 minus x by 2 is half of 4x. Okay, or we can say 4x is double of that. We found x, and x by 2 is the required angle, right? So in all, the problem should not take more than a minute, or in fact 50 to 60 seconds, right? Not more than that, if you are conceptually clear. Okay, so finally we got x by 2 as 20 degree. Once again, so many problems we have done in this session. I hope you enjoyed the session. Do revise all the problems, because you should be having good grip now. Okay, because we are doing so many problems, and I have really put up great efforts in making this collection. Okay, I'll see you in the next session once again. Bye bye.